All right, listeners, ready for a deep dive into something pretty amazing. We're talking AI that can act independently today.
Yeah, like set its own goals and gets things done.
Exactly. And the blueprint for this is something called the 369 Agentic Framework.
It's really a fascinating shift, moving away from AI as just a tool.
Yeah, more like AI as a collaborator.
Right, a genuine collaborator.
So to break it down, we're looking at this framework through the lens of actually building an agentic system.
Which is super cool.
Yeah, so the 369 Agentic Framework, it's got these 4 core components:
Interaction engineering.
memory, and execution engine.
All crucial for making sure our AI can act intelligently and independently.
So each component kind of builds on the last one.
Yeah, creating a system where the AI can understand its environment.
Learn from its experiences.
And make decisions to achieve its goals.
Okay, let's start with interaction engineering.
So that's the AI's ability to understand and respond to users.
Basically like teaching the AI how to have a conversation.
Right, and get things done in the real world.
So how does the AI even figure out what we're asking it to do?
Okay, so the first piece of this puzzle is context engineering.
Context engineering.
Yeah, it focuses on how the AI understands what the user wants.
Okay, got it.
And the framework uses 2 parts for that.
2 parts.
Passive goal creator and proactive goal creator.
Okay, so passive goal creator, what's that all about?
So the passive goal creator analyzes the user's direct instructions, like what they're actually saying.
Yeah.
It's like understanding the literal meaning.
Okay.
It uses natural language processing to break down those instructions and figure out the goal.
So if I tell the AI, write a blog post about the 369 Agentic Framework, it can figure out that's what I want.
Exactly.
Cool.
Now the proactive goal creator,
Okay.
that's where things get really interesting. This component, it goes beyond just understanding what's directly said.
Really?
Yeah, it uses things like what's on your screen, your mouse movements, even eye tracking data
Wow.
to understand your unstated goals.
It's like the AI can read between the lines.
Yeah, and anticipate what we need before we even ask.
That'd be incredible.
Right, much more intuitive.
Totally. But once the AI understands what we want, it needs a way to communicate back effectively, right?
Absolutely. And that's where prompt response engineering comes in.
Prompt response engineering.
Yeah, this makes sure the AI communicates with the core AI model in a consistent and effective way.
So it's like a universal language for talking to the AI?
You could think of it that way.
Okay.
The framework uses something called prompt template design and management,
Okay.
which creates reusable fill-in-the-blank structures.
For communicating with the core AI model.
Yeah,
I can see how that would be more efficient
way more efficient.
than starting from scratch every time.
Right. And then there's response processing and formatting.
Okay.
This is where the raw output from the AI model gets transformed into something we humans can understand.
That's crucial.
Right.
What good is a brilliant AI if we can't understand it?
Exactly.
Yeah.
So this component ensures the AI's responses are presented in a way that is clear, concise, and relevant to what the user asked for.
Whether it's text speech or even some kind of visual representation of data.
Exactly.
Okay, that makes sense.
So,
Now, I want to talk about something I think is really fascinating.
okay.
Giving these AI agents personalities.
Yes. The persona creator component.
Tell me about it.
So this is where we add that layer of personality to the AI agent, making it feel more relatable and engaging.
More than just purely functional.
Right. More like a collaborator or even a companion.
I like that. Okay, so how does that actually work?
Well, it starts with trait definition,
Okay.
choosing characteristics like helpfulness, creativity, or even a bit of humor to give the AI a distinct character.
So we could have different AIs for different tasks,
Exactly.
each with its own personality.
Yeah, you could have one that's playful and creative for brainstorming.
And then one that's more analytical for research.
Exactly. The possibilities are pretty much endless.
Okay, so how do we ground these personalities in some kind of context?
So for that, we use background context specification.
Background context specification.
Yeah, imagine giving the AI a backstory or a specific area of expertise, like history or culinary arts.
So it's like giving the AI a history and a set of experiences.
Precisely. And this background information can really inform the AI's responses.
Making them more believable.
More nuanced, more believable.
I like it.
And then, of course, there are communication style guidelines.
Okay.
This is where we decide how we want the AI to communicate, like formal, informal.
Oh, even sassy.
Uh-huh. Exactly.
I could see how having a consistent communication style would make interacting with the AI feel more natural.
Absolutely. It's all about making the user experience as smooth and enjoyable as possible.
Right.
But there's also a practical side to this with knowledge domain definition.
Knowledge domain definition.
We limit what the AI can talk about, ensuring it stays within its area of expertise and doesn't just start making things up.
We want to maintain the AI's credibility.
Right. We don't want it going off on tangents or giving inaccurate information.
Exactly.
And finally, we have constraint limitation setting.
Constraint limitation setting.
Yeah, this is where we define what the AI is not allowed to do or discuss.
So ethical and safety reasons.
Exactly.
This is essential for building trust and ensuring AI is used for good.
Absolutely.
All right, so we've covered how the AI interacts and communicates.
Uh-huh.
Now let's move on to the next core component.
Okay.
Memory.
Memory.
I'm guessing this is where things get a bit more technical.
It does get a bit more technical, but it's also fascinating to see how the framework tackles giving an AI agent a memory system.
Okay, so what are the different types of memory an AI agent needs?
Like us AI agents need both short-term and long-term memory.
Short-term memory.
Yeah, in this context, that refers to the AI's ability to retain information relevant to the current task or conversation.
So it's like our working memory.
Exactly.
The information we hold in our minds as we're actively thinking and problem solving.
The framework calls this FM context window management.
FM context window management.
It's about managing the AI's limited memory span and prioritizing the most relevant information.
Makes sense. Our brains can only juggle so much information at once.
Exactly. And AI models have similar limitations.
So the framework also includes configuration storage.
Yes, to keep track of the AI's settings and current status.
And recent event tracking to remember recent interactions.
Yes, so the AI can maintain context and continuity in a conversation just like we do.
That's pretty impressive.
But the real game changer is long-term memory.
Okay.
This is where the AI stores knowledge and learns from its experiences.
So it's like the AI's personal library of information and learned behaviors.
A perfect analogy.
Okay.
The framework provides data storage and retrieval mechanisms to tap into external databases and knowledge sources.
Giving the AI access to a vast pool of information.
It's like giving the AI access to the entire internet.
Wow.
Essentially, yes. But to make that information useful, we need knowledge-based integration.
Knowledge-based integration.
Yeah, this connects the AI to specific knowledge sources relevant to its tasks and goals.
So it's not just about having access to information, it's about having access to the right information at the right time.
Precisely. And the final piece of the memory puzzle is learning and adaptation strategies.
Learning and adaptation strategies.
This is how the AI learns from its experiences, incorporates feedback, and updates its knowledge base over time.
So it's not just about remembering, it's about learning and getting better over time.
Exactly. This is what allows the AI agent to continuously improve its performance and adapt to new situations.
This is all fascinating stuff.
Yeah, I know, right?
We've covered how the AI interacts with the world and how it remembers and learns.
Yeah.
But there's still a big piece missing. How does it actually decide what to do and make plans to achieve its goals?
That's where our next core component comes in. Planning.
Planning.
And that's exactly what we'll be diving into next.
I'm ready to plan ahead.
Me too.
All right, let's tackle the next core component of the 369 Agentic framework.
Planning.
Planning. This is where the AI goes from understanding and remembering to actually making decisions and taking action.
Yeah, you can think of planning as the AI's strategic thinking component. It's
Yeah.
how the agent figures out the best way to achieve its goals.
Whether those goals are set by the user or, generated proactively.
Right, through that context engineering we talked about earlier.
So it's like the AI is creating a roadmap for getting things done.
Exactly. The first step in that process is plan generation,
Plan generation.
which involves breaking down the task into manageable steps.
Okay.
And the framework offers two approaches here.
Two approaches.
Yeah, single path plan generator
Okay.
and multi-path plan generator.
I'm guessing single path is more straightforward.
It is the single path plan generator creates a linear sequence of actions like a step-by-step checklist.
Okay.
Works well for simpler tasks with a clear path to completion.
What about more complex situations where there might be multiple ways to achieve a goal?
That's where the multi-path plan generator comes in. This component explores different options and creates a more dynamic plan.
So the AI can adapt.
Exactly. Adapt to unexpected situations and choose the best course of action as it goes along.
That sounds incredibly useful, especially for tasks that require a bit more flexibility and problem solving.
It is the next stage of planning, involves model querying.
Model querying.
This is how the AI interacts with the core AI model, which is essentially the brain that powers the agent's decision-making.
So it's like the AI is consulting its inner genius to figure out the best plan.
You could say that there are two main ways to do this.
QA.
One-shot model querying
Okay.
and incremental model querying.
Hmm.
One-shot querying is like getting the whole plan up front.
Okay.
It's quick, but might not be as adaptable to changes.
And I'm assuming incremental querying is a more iterative approach.
Exactly. It involves building the plan step by step, allowing for adjustments and refinements as new information becomes available.
That sounds like it would be particularly valuable in unpredictable situations where the AI needs to adapt on the fly.
It is the final stage of planning, is plan reflection.
Plan reflection.
Focuses on evaluating and refining the plan before putting it into action.
So it's like a final quality check.
Exactly. There are 3 levels of reflection.
3 levels.
Self-reflection, where the AI checks its own plan for weaknesses or inconsistencies.
Okay.
Cross-reflection, where multiple AIs can compare and critique each other's plans.
Interesting.
And human reflection, where human experts can provide feedback and guidance.
It's fascinating to think about AI agents working collaboratively and even learning from each other.
It's an area of active research, and the 369 Agentic framework is designed to support these advanced forms of AI collaboration.
All right, so we've walked through the planning stage. The AI understands the user's goals, has a plan to achieve them, and has even double-checked its work. What happens next?
That's where the final core component comes in, the execution engine.
The execution engine.
This is where all the planning and preparation translate into real-world actions.
So the AI finally gets to put its plan into action.
Exactly. The execution engine has 3 main parts.
3 parts.
Task execution,
Okay.
tool agent management,
Okay.
and multi-agent cooperation.
Got it. Let's break those down, starting with task execution.
Okay.
How does the AI actually carry out the steps in its plan?
That's the role of the task executor.
Task executor.
It handles the individual actions needed to complete the plan, which might involve interacting with external systems, software, or even physical devices.
So it's like the AI's hands and feet in the real world.
A good analogy, and of course we need a way to monitor the progress of those tasks.
Right.
That's where the task monitor comes in.
Task monitor.
This component tracks the execution of the plan, making sure things are on track and alerting the AI to any problems or deviations.
Like a project manager built into the AI agent.
Exactly. Now, the next part of the execution engine is tool agent management.
Tool agent management.
This is all about giving the AI access to external resources and even other AI agents to help it achieve its goals.
So the AI can delegate tasks and collaborate with other AI specialists.
That's amazing, isn't it?
It is. So the tool agent selector is responsible for identifying and choosing the right tools or agents for a specific task.
Right. And if the right tool doesn't exist, the tool agent generator can even create it on the fly.
Wow, that's incredibly powerful.
Right.
It means the AI isn't limited to its own pre-programmed capabilities.
Exactly. And that brings us to the final piece of the execution engine, and perhaps the most exciting aspect of the entire framework.
Get you.
Multi-agent cooperation.
Multi-agent cooperation. This is where multiple AI agents work together to achieve a shared goal, right? It sounds like something out of a science fiction movie.
It is a fascinating area of research, and the 369 Agentic framework is designed to make this type of AI teamwork a reality.
So how does it work? Do the AI agents just decide to work together?
There are different mechanisms for coordinating multi-agent cooperation.
Okay.
The framework supports voting-based cooperation, where agents vote on the best course of action.
Interesting.
Role-based cooperation, where agents have specific roles and responsibilities. And even debate-based cooperation, where agents engage in a structured debate to reach the optimal solution.
It's incredible to think about AI agents engaging in these complex forms of collaboration. It's like they're forming their own little societies.
It is a fascinating thought, and as AI technology advances, we're likely to see even more sophisticated forms of multi-agent collaboration emerge.
This has been an incredible journey through the 369 Agentic framework. We've gone from the AI understanding its goals and planning its actions to actually executing those plans and collaborating with other agents. It's a truly comprehensive framework for building intelligent and autonomous AI systems.
It is the 369 Agentic framework represents a significant leap forward in AI development, and it has the potential to revolutionize the way we interact with technology and automate complex tasks.
All right, I'm ready for the final part of our deep dive. What else do we need to know about the 369 agentic framework?
Let's shift gears and talk about the responsible AI plugins that are integrated into the framework.
Responsible AI plugins.
Yeah, these are crucial for ensuring that AI agents are developed and deployed ethically and safely.
That sounds important. We've touched on the ethical considerations throughout our discussion, but I'm eager to learn more about how the framework specifically addresses these concerns.
That's a great point, and that's exactly what we'll be diving into next.
So we've talked about how this framework gives AI agents incredible abilities to learn, plan, and act.
Right, like a comprehensive system.
But as with any powerful tech, there are concerns about safety and ethical implications.
Absolutely. Building intelligent AI is only part of the challenge.
We also need to make sure it's used responsibly, right?
Exactly. That's where the responsible AI plugins come in.
The responsible AI plugins.
These are built right into the 369 agentic framework.
So these plugins, what specific aspects of responsible AI do they address?
The framework tackles this very systematically. It includes plugins for risk assessment and monitoring,
Okay.
transparency and accountability, safety and control,
Okay.
versioning and management,
Got it.
and model selection and reliability.
So each one plays a crucial role.
Yeah, ensuring AI agents are developed and deployed ethically and safely.
Let's start with risk assessment and monitoring. What does that involve?
You want to proactively identify and mitigate any potential risks associated with the AI's actions.
Right.
That's where the continuous risk assessor comes in.
Continuous risk assessor.
It's constantly evaluating the AI's behavior.
Like a built-in safety net.
Exactly, designed to detect any red flags and take steps to prevent harm before it happens.
It's like a guardian always watching.
Exactly.
Okay, what about transparency and accountability? How does the framework make sure we can understand the AI's decisions?
This is where the black box recorder comes in.
Black box recorder.
Keeps a detailed log of everything the AI does.
Providing a record.
Yeah, of its actions and decisions.
So if something unexpected happens, we can trace the AI's steps to understand why.
Exactly. It's all about creating an auditable trail.
I see, but transparency goes beyond just logging actions, right?
Right. The framework also has an explainer component that can break down the AI's reasoning process.
So we can understand why the AI makes a certain decision.
Yeah, and within this explainer, there's a fascinating component called the AI bomb registry.
The AI bomb registry.
Stands for AI Bill of Materials.
Okay, what's an AI bill of materials?
Think of it like a detailed ingredients list for the AI. It records all the components that make up the AI agent.
So the training data, the algorithms, everything.
Exactly. It's a complete transparency report showing exactly what went into building the AI agent.
That's a great step toward building more responsible AI.
Right.
Okay, now let's move on to safety and control.
Okay, so what mechanisms does the framework have to make sure AI agents operate within safe boundaries?
I'm really curious about this.
One key element is the use of guardrails.
The guardrails.
These are rules and restrictions that define what the AI is allowed to do and what information it can access.
Keeping it from going into dangerous territory.
Exactly. Preventing it from accessing sensitive data, generating harmful content, or taking actions with negative consequences.
I see. And to make these guardrails even more robust, there are multimodal guardrails.
Right.
So what makes multimodal guardrails different?
Traditional guardrails might focus primarily on text-based input and output. Multimodal guardrails extend those safety measures to cover all sorts of data the AI might interact with.
So images, audio, video, even sensor data.
Exactly.
It needs to be able to safely interact with all that.
Right, and with these multimodal safeguards in place, we can ensure the AI operates responsibly.
Okay, what about versioning and management? I imagine keeping track of different versions of these AI agents can get complicated.
Definitely, especially as AI technology is constantly evolving.
So how do we keep track?
That's why the framework includes a co-versioning register.
A co-versioning registry.
It keeps track of different versions of all the AI components, ensuring compatibility.
And you can roll back to previous versions.
If needed.
That's like a change log.
Exactly. It's essential for maintaining control and transparency.
Finally, let's talk about model selection and reliability. How does the framework ensure we're using the right AI models and that they're performing reliably?
This is crucial for trustworthy AI. The framework is designed to support various core AI models.
Giving developers flexibility.
Right, and control, allowing them to use external models, fine-tune models, or even custom-built in-house models.
Okay, that flexibility is important, but how do we make sure those models are actually reliable?
That's where in-version programming comes in.
In-version programming.
It uses multiple versions of the same AI model simultaneously.
Simultaneously.
Yeah, instead of relying on just one model, you have multiple models working in parallel. and their outputs are compared and validated.
So if one model makes an error, the others can act as a check.
Exactly. It's like having a team of experts double-checking each other's work.
That significantly increases reliability.
Right, and reduces the risk of errors or biases.
It's like a safety net built into the AI.
That's a great way to put it. The 369 Agentic framework is designed with both power and responsibility in mind.
This deep dive has been incredible. It's clear the 369 Agentic framework isn't just about building intelligent AI. It's about building AI we can trust.
And that's essential.
We've seen how these AI agents can learn, plan, and act in the world.
Right.
And we've also seen how the framework prioritizes responsible AI development through safety and ethical considerations.
It's been a fascinating exploration, and I hope it's given you a new appreciation for the possibilities of Agentic AI.
It definitely has. It's exciting to think about the potential of these AI agents to solve complex problems and make our lives easier.
And more efficient.
But it's equally important to remember the importance of responsible development and ensuring these powerful technologies are used for good.
The future of AI is in our hands.
And it's up to all of us to shape it responsibly. Thanks for joining us for this deep dive into the 369 Agentic framework. It's been truly enlightening. Until next time, keep exploring, keep learning, and keep asking those important questions.